Math is a wonderful thing. Math is a really cool thing.
Alright, so the objective for this video is to discuss how to solve equations with variables on both sides. We have here some steps that we can follow to guide us how to solve equations with variables on both sides. First, check if you have any parentheses. Next, check if we have any like terms on each side of the equation. And then, you move the variable to the other side by either adding or subtracting. And then, you undo a number either by adding and subtracting. And then, you undo the multiplication or division. So in this example, I have 7k minus 4 equals 5k plus 16. So we don't have any parentheses, so we don't need to distribute anything. Second, there's no like terms on this side. Likewise, on this side, there's no like terms. Note that I have here 7k and a 5k on the right side. So we can either undo 7k or 5k. In our case, we are going to undo the variable that has a smaller coefficient. In this case, 5k has a smaller coefficient compared to 7k. To undo 5k, we are going to subtract 5k to both sides. So right now, we are using our subtraction property of equation. So 5k minus 5k using inverse, this will cancel out. So this is your additive inverse. Bring down your 16. 7k minus 5k is 2k. Bring down your minus 4. Next, move numbers to the other side by either adding or subtracting. So here, my variable is on the left side of the equation. So we need to undo minus 4. To undo minus 4, we add 4 to both sides. So right now, we are using addition property. Once we cancel negative 4 and 4, that's actually your additive inverse. So this is your additive inverse. You'll get 2k equals 16 plus 4 is 20. Using our division property, divide to both sides. And then your multiplicative inverse, okay, when you cancel this, that's your multiplicative inverse, you'll get k equals 10. We're going to use our substitution property. Replace your k by 10. 5 times k, and again, replace your k by 10. Okay, so we are verifying if indeed the left side is equal to the right side if k equals 10. If the left side is equal to the right side, it means that the answer that we got is correct. So 7 times 10 is 70. 70 minus 4 will give us 66. 5 times 10 is 50 plus 16. 50 plus 16 will give us 66. Since the left side is equal to the right side, we can say then that our k equals 10. Okay, next example, I have here 2 times the quantity c minus 6 equal to 9c plus 3. In this case, we have a parenthesis on the left side of our equation. So let's get rid of this parenthesis. We can do that by distributing our constant 2 to c minus 6. So right now, we are using our distributive property. 2 times c is 2c. 2 times minus 6 is minus 12. Bring down the right side. Next, check if we have any like terms. We don't have any like terms here, and we don't also have any like terms here. Now, I have here 2c and 9c. Since this one has a smaller coefficient, let's get rid our 2c first. So subtract 2c to both sides Using additive inverse, we can cancel this, bring down your negative 12. 9c minus 2c is 7c. Bring down your plus 3. Now your variable is on the right side of our equation. So let's get rid our constant 3 here. So we can undo this by subtracting 3 to both sides. So we are using our subtraction property of equation. Using additive inverse, we can cancel this to get 7c, and then on the left side we'll get negative 15. Next, we need to undo your 7 besides the variable c. Note that this is 7 times c. It's a multiplication. Okay? To undo multiplication, we divide both sides. So we are using our division property. Right side will get c equals negative 15 over 7. Since we cannot simplify negative 15 over 7 into a more simplified fraction, we can leave our answer as negative 15 over 7. Okay, don't convert your answer as a decimal. Now using symmetric property, it says here negative 15 over 7 equals c. We can also write this as c equals negative 15 over 7. And again, this is using our symmetric property. Alright, third example. So I have here 2/3 times the quantity 6x plus 3 equals 4x plus 2. Okay, we have here a parenthesis. So let's get rid of our parenthesis. Now we have different ways on how to solve this. First, I'm going to show you how to solve this problem using distributive property. Okay, so 2 times 6x, it will just be equal to 4x, and then 2/3 times 3 will give us positive 2. If you would like to check your answer, we can use our Casio to verify that 2/3 times 6 is equal to 4. So using our Casio, so 2/3, you can write this as, or you can type this one in as 2 ABC 3, that's your 2/3, times 6, and that's equal to 4. Okay, next, 2/3, 2 ABC 3 times 3 is indeed equal to 2. Okay, so let's continue. So our right side is equal to 4x plus 2. Using one of the properties of equality, okay, if you check the left side, it is actually equal to the right side. This property is what we call reflexive property. Okay, the one that we discussed the other day. Now, whenever we have a reflexive property, we are going to say that we will have many solutions. As long as the left side is equal to the right side, we can stop there and say, all right, we will have here many solutions. Compared to the first question that we did, this one we only have one solution. It's just negative 15 over 7. Similarly, this one over here, we only have one solution. And the solution is k equals 10. But in this case, we had many solutions. So once you notice that the left side is equal to the right side, you can stop and say, we had many solutions. Let's say you would like to continue to solve this problem. Let's say we are going to undo our variable x. So subtract 4x to both sides. Using additive inverse, we'll get 2 here equals 2. So 2 is equal to 2. Okay, note that we don't have any more variable. Note that this is a true statement. And if we have a true statement, it means that we have many solutions. So we don't really need to show these steps. As long as we have reflexive property, that is the left side is equal to the right side, we can say that we have many solutions. So many solutions, you can have more than one answer. So if you plug in a number to your x, let's say 7. So 4 times 7 plus 2. Here, replace your x by 7 also. So when you check and simplify this one, note that the left side will be equal to the right side. Now, let's say instead of replacing x by 7, you can replace x by 0. And again, you will have another true statement. So 7 is a solution, 0 is a solution. So any number that you plug into your x will also be a solution. And that's the meaning of an equation that has many solutions. Alright, next question or next example. I have here 3 times the quantity 2f plus 4 equals 2 times the quantity 3f minus 2. Alright, so we have here a parenthesis. So let's undo our parenthesis by using our distributive property. This is 6f. 3 times 4 will give us 12. Do the same thing on the right side of the equation. 2 times 3f, it's 6f. Then 2 times negative 2 is equal to negative 4. Undo our variable. Well, we don't have any like terms here, no like terms, so we have to undo the variable. Subtract 6f to both sides. Using additive inverse. So we have here 12 equals negative 4. Is 12 equal to negative 4? This one is false. This will never be true. So whenever you have an equation wherein the last step is that you have the left side not equal to the right side, you will have a false statement. The answer for this is no solution. It means that there is no real number. There's no possible value of f so that the left side will be equal to your right side. So there's no solution for this particular equation. Alright, let's proceed to the next example. So note that we have a parenthesis on the left side of the equation. So distribute 6 to your 3a, you'll get 18a. 6 times 1 is plus 6. Bring down your minus 30. Distribute, you'll get 6a minus 12. Now note that on this side of our equation, we do have like terms. So your 6 and negative 30 are like terms. So we have to combine these two first. So 6 minus 30 is equal to negative 24. Bring down your 18a equals 6a minus 12. We don't have any like terms here, and we don't have any more like terms on this side of the equation. Next, let's move the variable. So I have here 18a, 6a. This one has a smaller coefficient. So let's undo this one using subtraction property. We'll get 18a minus 6a is equal to 12a. Bring down your negative 24 or minus 24. Cancel this one out using additive inverse. Bring down your negative 12. Undo our negative 24 by using addition property. Add 24 to both sides. Inverse. Bring down 12a. Negative 12 plus 24 is equal to 12. And then using division property, we will get a equals 1. Alright, let's check our answer. 6 times 3a. My a is equal to 1. Plus 1. minus 30. Is this equal to 3 times 2 times a? My a is again equal to 1 minus 4. Okay? So let's verify if this left side is equal to our right side. So using our GEMDAS, 3 times 1 plus 1 is 4 times 6. It will be 24 minus 30. It's equal to negative 6. Let's check the right side. This is just equal to 2 times 1 minus 4. It's negative 2 times 3. We'll get negative 6. So the left side is equal to your right side. Therefore, we can say that a equals 1 is the solution of this equation. Now, please don't be confused, okay? You might think that because we have the left side equal to your right side, you might say that this one has many solutions. Remember, we have this because we are checking if a equals 1 is the correct answer for this equation. So we had here one solution, okay? We have one solution, and we are just checking if this one is going to work. All right, let's say we have a fraction. All right, so whenever you have a fraction, the first thing that you have to do is to get rid of your denominator. So how can we do this? We are going to get the LCM of 2, 4, 28, and 7. So how do we get the least common multiple? Well, what we learned before from grade 6 or grade 7 is to list the multiples of your numbers. Let's say 2, 4, 28, and 7. So write the multiples of 2. It's 2, followed by 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and so on and so forth. 4 will get 8, 12, 16, 20, 24, 28, 32, 36, and so on and so forth. 28 will get 28, 56, and so on and so forth. 7, 14, 21, 28, we'll have 35, and so on and so forth. So note that we have here some common multiple, okay? But we have to get the smallest, okay? Note that, let's see, which one is common to all of them. Seems like this one has 28, this one has 28, this one has 28, and 2 has also 28. 28 is the smallest number that is common to these 4 numbers. So 28 is your least common multiple. What we have to do is to multiply each of this by your LCM. All right, 28. So meaning you'll get 28 times 3 halves, n. So we just actually distributed 28. 28 times 5 over 4. Then 28 times 89 over 28. And finally, we'll have 28. We don't have space.
Let's move this one. Okay.
So we have 28 times 3 over 7n. Alright, next, simplify our 28 times 3 over 2. So we have to do 28 times 3 over 2. We'll get 42. Bring down n. Next, we multiply 28 times 5 over 4. We are going to get 35. (28) times 89 over 28 is just equal to 89. and then 28 times 3 over 7n, we are going to get 12n. Now to check our answer, let's use our calculator. So we'll have here 28. So let's show this one. 28 times 3 ABC2 will get 42n. 28 times 5 over 4 will get 35. This one, 28 times 89 over 28, we can actually just cancel this to get 89. And finally, our 28 times 3 over 7 times 3 over 7 is equal to 12. Or you can just divide 28 by 7, that's 4. 4 times 3 is equal to 12. Alright. Next, we don't have any more fractions, right? We don't have any more denominators. Then, let's use again these steps. We don't have any more parentheses. We don't have any like terms on each side of the equation. Let's move our variable. So I have here 42n. This is 12n. Let's undo the n that has a smaller coefficient. Subtract n to both sides. Subtract 12n to both sides. We'll get 30n plus 35, 89. And here, subtract 35 to both sides. So 89 minus 35 is equal to 54. This is equal to 30n. Then divide by 30 both sides. We'll get n equal to 54 over 30. And then we can further simplify this as 9 over 5. Okay, divide this by 6 and then divide this by 6. Or we can check our answer by doing it this way. So type in your 54 ABC 30. Okay, then when you press EXE or execute, it will give you the simplified fraction 9 over 5. Alright, so here we go. This is our answer, 9 over 5.
Math is a wonderful thing. Math is a really cool